Okay, this next portion, we call it completing the square. This exercise is called completing the square. Okay, there's a lot of very good YouTube videos out there explaining like the logic or the reasoning or the representation behind this exercise. Okay, I'm gonna show you. Okay, but what is completing the square? So we're gonna use this idea of this. Let me rewrite this identity already here. So you both learned that a plus minus b squared equals a squared plus minus 2ab plus b squared. Okay, I think we did this a few months ago. A few months ago, in the start of the year. Okay, so I'm going to utilize this identity. How do I utilize it? If I have an expression that looks like this, I can factorize it to look like this. Okay, now why do I want to factorize my expression into perfect squares? These are called perfect squares. Why do I want to factorize my expression into perfect squares? It's because, as you can see in the previous section, if I have a perfect square in the equation, I can just square root both sides to figure out the value of x. Okay, so I'm going to take one step further and try to make expressions into completed squares. Okay, now I'm going to show you the technique first, and I'm going to explain a little bit why this technique works. Okay, let's take a look at 21 first. What must be added to each of the following expressions to make it a perfect square? We will take a look at the x term, x squared plus 6x. Okay, in fact, I'll just look at the coefficient of x. This is 6. Okay, what I'm going to do is I'm going to divide this by 2. And I'm going to square it. Okay, this is what I need to add to this expression so that it becomes a perfect square. Okay, and this factorizes into x plus 6 over 2 is 3 squared. So if I add 6 over 2 squared, I can factorize this entire expression into x plus 3 whole thing squared. Okay, another example. X squared minus 3x minus 3. Okay, plus, I'm going to divide this and then square it. And then this entire expression factorizes into x minus 3 over 2 whole thing squared. Okay, again, this is called completing the square. Okay, so why does this work? If you take a look at the first line, this first line, I can rewrite it as, x squared plus 2 times 3 times x plus 3 squared. And this factorizes into x plus 3 squared. Okay, so by adding 6 over 2 squared, I completed the square. So this is what this exercise is about. Okay.
I don't really get it.
Yeah, you won't get it. It's gonna take some practice to get. But the technique, first at this point, just really understand the technique first. What are you doing? You're just dividing this by 2 and then squaring it. And you add it to expression to complete the square. Okay, I'll explain a little bit more the geometrical interpretation of this. Okay, so that's what I'm gonna do. You can find this on YouTube, by the way. So I basically just stole this from YouTube. Oops. Okay, so we're just gonna consider this example here: x squared plus 6x. Okay, so how do I represent this? X squared, I can represent this using a square with sides, with the sides length x. Okay, so the area is x squared. Okay, 6x, I'm going to cut it in half. So this is 3. So the area of this rectangle is 3x. I'm going to put it here as well. It's 3. So the area of this rectangle is 3x. Okay, you see this big gap in the corner here? Okay, what must I add to this so that it becomes a complete square, or yeah, a perfect square? So I need to add a square with a side of length 3. So I needed to add 9, which is what I did here. So yeah, this is literally completing the square. Okay, and once you patch in this empty blue color square, the total area of the entire square is x plus 3 squared, which is what you got here. Okay, so yeah, so what you're doing is, again, you're taking a square and a rectangle, you break that rectangle in half, and then you complete the square. Okay, another illustration here. So let's say I have let me just erase everything out. I'm going to use part B as an example. Okay, so let's say I have I have 2 rectangles, one square and a rectangle this time. So the rectangle now is 3x. Okay, so the exercise is I'm going to cut this rectangle in half. Cut it in half. Okay, so this is 3/2, such that the area of this rectangle is now 3/2x. I'm going to split the other half and I'm going to put it here. This is also 3/2. Okay, so there's an empty space here. What must I add so that I can complete the square? I need to add 3/2 squared, which is what I did here. Okay, once I patch in the empty space, the entire area of the big square is x minus 3/2 squared. So I forgot a negative sign.
What?
Ah, now only you ask what? Talk so long, you only say what? Which part do you still not get?
Like, why you have to divide it by 2 and square it?
I just draw the picture at the bottom. So I take the red color rectangle, I break it in half. And this red color rectangle, I broke it in half already. I put the other half at the bottom here. Okay, then to complete the square, I add in the blue color square.
Oh,
Okay, why do I need to break it in half? It's because if I don't break it in half, I need to add a variable. Okay, so instead of adding just a number, I need to add x and I need to add number. Okay, I don't want that. I don't want that. I want to add as few things as I want into this. Okay, now you can do all the questions. You can live a good long life without knowing. Okay, in fact, you can live a good long life without knowing math. Okay, but you can live a good long life. You can do all the questions without understanding why this works and just going with the flow and just doing it. Okay. For me, when I first learned this, I just went with it. It's only until I keep doing until I reach math, right? Maybe a few months down the road, then I finally it clicked, right? Okay, this is why we are doing it. Okay, it's like when you first learn addition, you be like, I don't need addition. When you first learn multiplication, I don't need multiplication. It's the same thing here. Okay, so this question says solve the following equations by completing the square, giving answers correct to 2 decimal places. Okay, so if you try to factorize this expression, you can't. Okay, so try to factorize it. Okay, you can try all sorts of combination, it won't work. Okay, so under this situation, you have two options left, right? Either you complete the square or you use something called the quadratic formula. I will go through the quadratic formula next week. Okay, so how do I complete the square? It's the same technique that we've went through previously. We're just gonna apply it into solving equations. Okay, for me, what I'm gonna do is I'm gonna move my constant to the other side. Now this is one method. Another method is just to leave it there. Okay, this is actually simple. I move my constant to the other side, which breaks the principle of solving quadratic equation already. Okay, so previously I told you to move everything on one side equals 0. Okay, so now I'm just gonna move my 6 to the other side. So it becomes x squared plus 4x equals 6. Okay, now I'm gonna complete the square on the left-hand side by looking at the coefficient of x. This is 4, so to complete the square, I'm gonna add 4 divided by 2 squared. Now this is an equation. Whatever I do to the left, I need to do to the right. So I'm gonna add 4 over 2 squared here as well. Okay, then on the left, this is already a completed square. So I'm gonna factorize. This is x plus 4 over 2 is 2 squared. Okay, on the right, this will be 10. You can key this in your calculator, by the way. Okay, now you see why we learn completing the square. After you complete the square, we can actually solve this equation to get a pair of irrational solutions. Okay, this equation should be really familiar because we did this last week. I'm going to square both sides. So x plus 2 equals plus minus square root 10. Then I'm going to move my 2 to the other side. So x equals -2 plus minus square root 10. So this is the exact form. Okay, to evaluate this, just use your calculator. Okay, if I evaluate this, I will get 1.16 or negative 5.16. Okay, they say to 2 decimal places, so these are rounded to 2 decimal places. The same thing, I will move my constant to the other side first. Okay, so x squared minus 5x equals 3. Okay, then I want to complete the square on the left-hand side. So look at the coefficient of x. This is 5 divided by 2 squared plus 5 over 2 squared. Okay, to balance the equation, whatever I add to the left, I need to add to the right as well. So on the right, I just add 5 over 2 squared.
Wait, does it have to be minus 5 over 2?
No need, it's always add. Why? Because if you recall your identity, right? Okay, it's a plus minus b squared equals a squared plus minus 2ab plus b squared. So whatever it is, if it's plus or minus, you see your b squared is always positive. And the reason being is if you do it manually, let's say a minus b times a minus b, right? Your b squared term is negative b times negative b, right? So you always get positive. Right. So in completing the square, you always add something to it.
Okay.
Okay. Now, after this, I'm going to factorize. Okay, if I factorize, this will be x minus 5 over 2 squared. It's minus. Why? Because whether it is plus or minus after you factorize depends on the sign of your x term. Okay, so a common mistake here, students will always write plus when it's supposed to be minus. Okay, and I'll just simplify the term on the right. Okay, this is 37 over 4. Okay, then now I can square both sides. Okay, so this should be x minus 5 over 2 plus minus square root 37 over 2. Okay, why is it 2? Because if I square root a fraction, once again, if I square root a fraction, I square root the top, I also square root the bottom. If I square at the bottom, it just becomes 2.
Wait, why is it x minus 5 over 2? What happened to the 5x?
I factorized it already. Yeah, when a squared minus 2ab plus b squared, if I factorize this, it becomes a minus b whole thing squared. Your 2ab is gone. It's not gone, but it's factorized. Okay, common question.
Oh, okay. Anyway. Yes, okay.
Okay, then I just move my 5 over 2 to the other side. And I can combine it into a single fraction. Again, so this is my exact form. To get the evaluated answer, I just key my calculator. So it's 1.30 or negative 0.70. They're both positive. Okay, so for part E, it will be a little bit tedious. Now you realize that from part A, B, C, D, all your coefficients of x squared is 1. Okay, so if you take a look at this one here, 1, 2, 3, 4, they're all 1. Okay, what happens if it's not 1? You need to make it 1 first. Okay, so this is what I'm going to do. I'm going to move, same thing, I'm going to move my constant to the other side. I'm going to move this over. Okay, and I'm going to factorize this, the remaining term on the left. So it'll be 2 times x squared plus 4x. Okay, 5, I move it to the side, it becomes negative 5. Okay, then what I'm going to do is I'm just going to look at the terms inside the bracket, and I'm going to complete the square inside the bracket. So the same process, I look at the coefficient of x, this is 4, divided by 2, and then square it. So 4 divided by 2, square. So it's the same process, it's just that you need to factorize your 2 out first. Okay, now same thing, whatever I added to the left, I need to add back to the right. And so I'm going to add 4 over 2 squared times 2. Common mistake here is students will forget the 2 here. Why is there a 2? Because when you add 4 over 2 squared, this is actually multiplied by 2 as well. Okay. There's a faster way of doing, there's another way of doing this. I'm showing you this is because it's more applicable if they ask you to complete the square for an expression. Okay, so there's a difference between completing the square for an expression and completing the square for an equation. Okay, there's a slight difference. Okay, so everything here is, the only new thing is you just need to factorize the 2 out. Okay, and when you patch up when you balance your equation, you need to remember to multiply the 2 back. Okay, again, I'll show you a faster method, but let me just continue this first. Okay, then the rest should be quite straightforward. So it is 2 times x plus 2 squared. Okay, then on the right, I just key my calculator. Okay, this is 3. Then I divide 2 on both sides. And I square it. Okay, then I evaluate this is negative 0.78 or negative 3.22. Okay, there's a faster way of doing this, and this only applies when you're doing equation. Okay, same process. I'm going to move my 5 to the other side first. I should write this in a different color. Hang on, I'm writing purple. Okay, move my 5 to the other side, so it's negative 5. Okay, then again, my goal is to make the coefficient of x squared 2, so I'm going to divide 2 throughout. Okay, so x squared plus 4x equals negative 5 over 2. So now it's just a little bit easier to complete the square. So same thing, I add 2 square here and add 2 square here. Okay, then I factorize. Okay, and I get back the same answer.